Okay? And the roughness of the surface can be characterized by a coefficient, mu. Okay, we use mu to denote the coefficient of the friction. So please note that mu is just a coefficient. It doesn't have a unit. It's not the frictional force itself. The frictional force has to be the coefficient. If you want to calculate frictional force, it's kind of the multiply. You have to multiply the coefficient to the normal force, okay, because it's perpendicular to both the roughness and the load. This is actually true for kinetic friction. So kinetic friction is relatively easier to calculate. Fk, K is kinetic. Okay. Fk equals to mu Kn. So usually you can find the coefficients from a table, and if you know the normal force, then you can calculate the static kinetic friction. Okay. It wouldn't change anyway. If you change the speed of the object, the kinetic friction will keep the same. Okay. It wouldn't change with speed. And the static friction, Fs, okay, it's more complicated than the kinetic friction. It's not given by an equation. It says that Fs is smaller or equal to mu s multiplied by n. Okay. So in other words, if you multiply mu s and n, this actually will give you the maximum possible value of the static frictional force. Okay. It wouldn't give you the actual value, the value of the actual frictional force. What do we mean by this? So for example, if you have some object, the weight, say the weight equals to 10 Newton. So from the force analysis, if the weight equals to 10 Newton, if this is a horizontal surface, then the normal force should also be 10 Newton, right? So that's a load. And if I tell you that mu s, I give you equals to 0.1, let's say 0.5. Okay, that's the coefficient of the static friction. So in this case, if I'm pushing it into this direction, from this direction, okay, with some external force, and so of course, if the force is not very large, I cannot move the object due to the frictional force. So you have some frictional force. If it's not moving, so you will have some static frictional force. So if that's the case, can you give me the magnitude of the static frictional force? Is it possible to get in this case, to get the value for the static frictional force?
Yes.
What's that?
US times N.
US times N equals to 5 Newton. Is that the static frictional force here? In fact, it's not. Mu s multiplied by n only give you the maximum possible static friction provided by the system. But the actual frictional force cannot be that may not be that value. It can be any value up to 5 Newton. Okay?
So after 5 newtons, it starts to move.
So in fact, it depends on the external force I applied. Okay. If I try like apply just 1 Newton force, the system will only give me 1 Newton frictional force. That's enough to compensate my external pushing force. So this will not move. So the system doesn't have to give me all the 5 Newton, right? In fact, you have a 5 Newton frictional force, it will be ridiculous. If I push it with 1 Newton force and then you have 5 Newton frictional force, that means the object will move in the direction opposite to my pushing. Okay, so that's really weird. In fact, so that's what happens if I give it 2 Newton force, the frictional force will be 2 Newton, exactly cancel my external pushing. If I give it 4 Newton force, the frictional force will be 4 Newton. If I give it like 6 Newton force, what is the frictional force?
5.
5, because you have some maximum possible value. Above that value, the system cannot give any more frictional force. So that, in that case, the frictional force is smaller than the external pushing, so it starts to move. Okay. So please note that this 5 Newton is the maximum possible value. It's up to, the actual value is up to that value. So, you know, sometimes, okay, you see those ADCs up to 20% discount, but in most cases, you don't get 20% discount. Okay, it's just, it could be anything less than 20%. So that's the static frictional force. And okay, of course, the direction. Frictional force is the resistance. So it's opposite to the direction of motion. This is straightforward for kinetic friction. Okay, when it's actually in motion, you know what is the direction of the motion. And so frictional force is opposite to that. And if it's not moving, for example, this object, I said I'm trying to push it to that direction, but it's not actually moving. I still say the frictional force to that direction. So in that case, I'm looking at the tendency of the motion without frictional force. So without frictional force, I will push this to that direction. To compensate that kind of tendency, against this kind of tendency, frictional force has to be in this direction. Okay. So for static case, it's not that straightforward. This is okay. So this is quite important in another case. Let's say if I have a truck, okay, and here someone try to push. The truck is moving to this direction. Okay. So this object also moving to this direction, right? If you have some velocity. Now, if I'm trying to, okay, I'm trying to push it from this direction. Okay, I give it a force. It's not in motion relative to the surface here. Of course, as a whole, it has some motion to that direction. So in this case, you will have some static frictional force in this direction. Please note that that's a static friction because when we talk about motion to determine the frictional force, we're talking about the motion relative to this contact surface. It's not the motion relative to the ground. So this object moving together with the truck to that direction, okay, relative to the ground. But relative to the surface here, this surface is not moving. So it's static friction. It's against to the external pushing force. So in this case, the static frictional force is actually in the direction of the motion. Okay, but that's not the relative motion. So, any question for this kind of things?
Could you go over that?
Okay.
Do you want to go?
So what I would like to emphasize is that we know that in this case, the box, the object, is actually have some motion to that direction, to the right direction. Okay. But this direct motion has nothing to do with the frictional force. Okay. Because that's the motion of the whole system. is relative to ground, not the contact surface. And the frictional force is completely determined by the motion of the box relative to its contact surface. But both the contact surface and the box moving to the same direction. So there is no motion between this object and this surface. So it's static friction if I'm trying to push in that direction. And the frictional force is static frictional force. It will against the external pushing force, right? I'm trying to push it to that way. So it moves to this way. It tries to move to this way. So the frictional force in this direction. So if you look at the whole system, it may appear a little bit funny because it has some velocity in this direction, okay, together with the truck, but the frictional force is still in this direction. So you need to think about the relative motion between this object and the contact surface, not the velocity between the object and the ground. Okay. Any question? Okay. In other words, if you try to start with the motion, you have to step inside of the truck. So the motion of the truck has nothing to do with the analysis. Okay. You cannot stand outside to look at it.